Let's simplify by combining radicals. Square root of 18 plus square root of 32. You cannot subtract this in the first place because they are not like radicals. Like polynomials, you can only combine those like terms. Here for radicals, you can only combine those radicals. What do you mean by like radicals? Examples of like radicals, let's say like radicals. When do you know if they are like radicals? Examples are square root of x, 2 square root of x. These are like radicals. Another one would be 3 square root of AB. Say you have 2 square root of AB. These are like radicals. They must have the same index and the same radicand, right? So 2, 2, AB, AB. Here, 2 index, X radicand. 2 index, X radicand. So these are examples of like radicals. If they are like radicals, you can combine them. And that means you can add or subtract the coefficients of the radicals, the numerical coefficients. And so if you have a square root of 18 plus square root of 32, you cannot combine this, right? You cannot add because 18 and 32 are different. So you have to simplify each of these radical in order to combine these two. And so we start by factoring 18. 18 is not a big number. So for instance, 18, what are the factors of 18? We can divide 18 by 2. All right, 18 divided by 2 is 9. 9 is a perfect square. How about 32? Can you divide 32 by 2? 30 divided by 2? 16. Is 16 a perfect square? Yes, this is the biggest perfect square factor. Although you can have 8 times 4. 4 is, let's say 32. 8 times 4, yes, 32, but 4 is not the biggest perfect square factor. The biggest perfect square factor is obtained if you have 2 times 16. 8 and 4, you cannot use that because 4 is not the biggest perfect square factor. You have to get the biggest perfect square factor. So now we have those factors. So 18 can be written as 9 times 2. How about 32? 16 times 2. Now, going back to the square root of 9 times 2. What's the square root of 9? 3. And 2 stays here inside. Plus 16. Square root of 16. You have 4. 2 stays inside the radical. So you have 3 square root of 2 plus 4 square root of 2. And in that case, you can now add your coefficients 3, 4. The coefficients of the radical square root of 2. We have 3 plus 4 square root of 2. What's 3 plus 4? You have 7 is square root of 2. So that's our combined. I mean, that's the expression combined. Or the sum of square root of 18 plus square root of 32. 7 square root of 2. You have a square root of 72 minus square root of 200. 72 is not a perfect square. And 200 is not a perfect square. So let's try to factor. Let's have 72. What do you think are the factors of 72? Let's start dividing it by 2. So we can always make use of these divisors. 2, 3, 5, 7, and so on. We start from 2. 70 divided by 2? 36. Oh, 36 is a perfect square. The reason why we're dividing it by the smallest prime number is that so that we can get the biggest perfect square factor. Okay, how about 200? Can you divide it by 2? 200 divided by 2. 100. Is it a perfect square? Yes, it is. All right, so now we have this. 72 can now be written as 2 times 36, and 200 can now be written as 2 times 100. Take the square root of 36 and 100. Square root of 36, 6. Square root of 2. Square root of 100, 10. And then square root of 2. combine like these coefficients of the radical. 6 minus 10. What's 6 minus 10? You have negative 4 square root of 2. Number 82, you have 4 square root of 300 minus 2 square root of 108 plus 3 square root of 200. 300, 108, and 200 are not divisible. I mean, are not perfect square. So let's look at 300. If we divide 300 by 2, what is it? It's 150. It's not a perfect square, right? So let's try another. 3. We divide this by 3. We only divide by 3. 100, and yes, that's a perfect square. All right. And then we have 108. 108. Can we divide it by 2? Yes, we can, but let's see. This 108 divided by this 54, it's not a perfect square. So let's try another. Can we divide it by 3? Yes, we can. So what's 108 divided by 3? It is 36. All right, so 3 and 36. All right, let me write here now for square root of 3 times 100 minus 2. 3 times 36. How about 200? We already factored a while ago, right? 3. That's 2 times 100. Okay. Let's get the square roots of all these perfect squares. Note that we have a coefficient for the radical, right? 4 square root of 100, 10. All right, so that would now be 4 times 10. 3 stays inside, square root of 3 minus 2. Square root of 36 goes out. We have times 6. Square root of 3. How about this? Square root of 100 goes out, so it's now times 10. Square root of 2. Now we have 4 times 10. 40 square root of 3 minus 12 square root of 3 plus 30 square root of 2. Not all of them are like radicals. These are square root of 3 square root of 3. This one is not. So we can only combine this. We can only combine 40 square root of 3 minus 12 square root of 3. What is 40 minus 12? All right, so we have 40 minus 12 square root of 3 plus the same 30 square root of 2. What's 40 minus 12? It's going to be 28 square root of 3. Just copy that 30 square root of 2. You cannot combine because they are unlike radicals. So we have this 28 square root of 3 plus 30 square root of 2.